Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.
These are the motion graphs. Okay, I'm going to draw a number of graphs to explain some things. First of all, let's look at distance time graph. Let's start with distance time graph. Or you can say displacement versus time. You know we use S for distance, right?
Yes.
So S over T, S against T, S against T, S against T, S against T, and so on. S against T, S against T, S against T. Let me see. Okay. The first one is if you have a line like this, then another one when it's going this way, curving up, when it's curving down, when it's just straight, sometimes when it is this way, when it's curving this way, when it's curving this way, sometimes when it's just on this axis and not moving at all. Okay, let me letter it or number it. 1, 2, 3, 4, 5, 6, 7, 8. You know, when you find the gradient of the slope of a distance against time, let me explain it first of all here. Are you listening?
Yes.
Okay, look at this. If you have distance against time, what will the gradient give us?
Distance and speed?
Yes, the gradient will give us speed because the gradient is a slope. Gradient or slope is equal to S over T, and S over T is speed. Now, is it not?
Yeah.
So the slope gives us the speed. The slope gives us what?
The speed.
For a distance against time graph, the slope gives us speed, V, or velocity. And if the slope is constant, it's just a straight line, it means it's a constant speed. For instance, number 1, you can see the speed is a straight line, isn't it?
Yeah.
So number 1 is what? Let's be defining it. Describe the motion. Number 1. Constant speed, is it not?
Yeah.
Why is it a constant speed? Because the slope is constant. It's a straight line. What can you say about number 2?
Accelerating.
Because the slope is getting steeper, or the line is getting steeper, which means slope is increasing, is it not?
Yeah.
And you know that the slope is speed. The slope is speed. And since it's getting steeper, higher slope means higher speed, because we've said that the slope is speed. So if the slope is constant, it is constant speed, that's number 1. But if the slope is getting higher, if it's getting steeper, it means increasing speed or acceleration. So let me write it: increasing speed, which is acceleration. That is
Increasing speed.
or acceleration. So let me just write increasing speed, which is acceleration. Let's go to number 2. Number 3, right? Rather. What's number 3?
Decreasing acceleration.
No. Check it. This is speed, distance against time. Distance against time.
That look like S.
S stands for distance now. Distance against,
Oh,
it's all about speed. The slope is all about speed, so you only talk about speed. So what's happening to the slope here?
it is increasing.
This is getting less steep now.
Oh, it's bending.
It's bending downwards. That means it's getting less steep. So it's a decreasing speed. It is what?
Decreasing speed.
What's another name for decreasing speed?
So, but I said decreasing speed.
I thought I heard increasing.
Oh. Decreasing acceleration.
No. It's not acceleration. Oh, maybe that's what you said. It is not decreasing acceleration. Decreasing speed simply means deceleration.
Oh.
Please don't mix it up, right? In fact, deceleration is negative of acceleration. Which is negative of acceleration, which is what?
Negative acceleration.
So if acceleration is A, deceleration is minus A. This one is A. Deceleration will be minus A. Because deceleration is negative of acceleration. First of all, tell me again, number 1 represents what?
Constant speed.
Because the line is straight, it has a constant slope, and the slope is speed. Number 2 is what?
Increasing speed.
Because it's getting steeper. So the slope is getting bigger, and the slope is speed, so that means increasing speed. Number 3,
Decreasing speed.
why?
Because the slope is getting
Smaller.
Decreasing.
The slope is decreasing, and the slope stands for what?
The slope stands for speed.
Speed. Since the slope is decreasing, that's decreasing speed. Another name for decreasing speed is what?
Deceleration.
Deceleration. Let's go to number 4.
No speed.
No speed, because it has no slope, it's a straight line. No speed means, what does it mean?
It's not moving.
Zero speed means rest. It's at rest. No movement. Number 5.
Number 5.
Can you see that the line is straight?
Yeah, but it's going down.
That means it's reversing.
Constant deceleration.
No, it's not a deceleration. No, this is about this distance against time. We will talk about the other one later. I don't want to mix it up. This is distance against time. So, and the line is straight. So this is still a constant speed. This is still what?
Constant.
But it is reversing. It's reversing. It's going backward at constant speed. So
So that's what they call it.
reversing at constant speed.
Oh, reversing.
What about number 6?
Number 6.
It's also reversing. It's also reversing, but it's getting less steep, is it not?
Yeah.
It's also going backward, but it is getting less steep. As you move forward, it's getting less steep. So what can you call this one? Reversing at decreasing speed. Did you see what I wrote?
Yeah.
It's reversing, but at decreasing speed, because it's getting less steep when it started, it was steep. As it moved forward, it became less. Did you see that? So, and remember, it's coming down, so it's reversing at decreasing speed. Let's go to number 7. What can you say about number 7?
Number 7, reversing in increasing speed.
Why did you say increasing speed? Because it's getting steeper, isn't it?
Yeah.
It's getting steeper, and it is coming backwards. So this is reversing at increasing speed. In other words, reversing and accelerating, because increasing speed is acceleration. I hope you know increasing speed means acceleration, right?
Yeah.
While decreasing speed means deceleration. So we could have said reversing at, for number 6, we would have said number 6 would have been reversing and decelerating. Number 7 would be reversing and accelerating. What can you say about number 8?
Number 8. Number 8 looks like no zero speed.
Or no movement, but it didn't move at all. Why is it different from number 4? Number 4 means it moved and then it stopped moving. Number 8, it didn't even move at all. So no movement from start. Okay, that is noted. Let me represent this again in a different way before we quickly answer our question. Go to the next page. Let me draw this. Let's quickly look at speed against time now, or velocity versus time. Still under motion graphs. Okay, let me still draw all these. Look at this. All right, let's see this. This one is now V against T, V against T, V against T. All of them are V against T, V against T. Are you listening? Are you listening?
Yes, sir.
Okay, let me draw the graphs. When it is straight like this, when it curves up, when it curves down, when it goes straight, when it goes down like this, when it goes this way, when it goes this way, when it goes which other way, when it goes this way, just in front, and then I can even represent A against T. Let me just do one more for A against T, and then another A against T here. You can just talk about it. Let's call this A against T a value here, and then another A against T here. Okay, just like we did in the other one, when you have velocity against time, are you seeing what I'm doing?
Yeah.
Velocity against time. What would the slope give you for a velocity against time? Let me draw the slope first, or gradient. When you find a gradient of a velocity against time, what are you finding?
Distance.
Remember, gradient or slope is
I mean speed.
no V over T. V itself is speed, or change in V over change in time. That will give you acceleration. That will give you what?
Acceleration.
So the slope for a velocity against time gives acceleration. Is different from the slope for a distance against time. Go to the previous page. The slope for a distance against time gives what?
Speed.
Speed. Because the slope is s over t. Slope is rise over run, which is s over t. That gives speed. But when you come to velocity against time graph, it's a different graph. Go to the next page. Yes. The slope gives what? Because the slope is v over t, rise over run. And v over t gives you what?
V over t gives you acceleration.
Because that's changing velocity over time. Okay, so what's happening to the acceleration here? In number 1, let's number it. 1, 2, as we did in the other one, 3, 4, 5, 6, 7, 8, 9, 10. What's happening in number 1?
Number 1 is acceleration.
What kind of acceleration? Check the slope.
Constant acceleration.
Why did you say constant acceleration?
Because it's moving up.
Because the slope is constant. It's a straight line. So number 1 is constant acceleration. Let's write it. Number 1, constant acceleration. Number 2.
Number 2, I think, is acceleration.
What?
Increasing acceleration.
Why did you say increasing acceleration?
Am I wrong?
You are right. That's correct.
Oh, because the slope is moving up.
Because the slope is getting bigger, it's getting steeper. And you know the slope is acceleration for a speed against time. That's a velocity against time. The slope is acceleration. So this is increasing acceleration. What about number 3?
Decreasing acceleration.
Decreasing acceleration because the slope is getting smaller. It's getting less steep. So that's decreasing acceleration. It's still accelerating, it's just that the acceleration is getting smaller. Decreasing acceleration. Number 4.
Number 4,
Yes.
rest.
This is speed against time. We don't mix it up with distance.
Okay. Then. Constant.
Constant speed because the speed is just the same. It's not changing. Constant speed. When something has a constant speed, does it have an acceleration?
Oh,
So constant speed means zero acceleration. Means what?
zero acceleration.
When an object has a constant speed, it means it has a zero acceleration. Number 5.
Number 5. Wait a second. It's going down. Speed is going down.
Speed is.
Deceleration.
How is it deceleration?
Huh?
How is it deceleration? Constant.
Deceleration.
Constant because it has a constant slope, constant gradient. It's a straight line. So that's constant deceleration. Deceleration. How about number 6?
Number 6. Number 6 is looking like and a decreasing deceleration.
Decreasing deceleration because it's a deceleration because it's getting less steep. This slope is getting lower and lower and lower. When you started it was high. As you are going it becomes lower. So this is a decreasing deceleration. Number 7.
Number 7 Number 7 looks like an increasing deceleration.
because it's getting more steep as we are moving down, and it's still a deceleration. So it's an increasing deceleration. Number 8.
Number 8 is rest.
Zero speed, because the speed is zero now, is it not? That's
Yeah.
correct. Zero speed, which is rest or no movement. It's different from number 4. Number 4 means it has a speed, but it is constant, right?
Yeah.
But this number 8 means it doesn't even have any speed at all. It's zero, because this place is zero for the speed axis. Okay, number 9. You are doing well.
Number 9. Oh, you are trying to change me. That is rest.
No, number 9, that's acceleration against time. Oh. It's number 9.
Acceleration. I did not add on that one. So, acceleration against time
Yes.
will be constant speed.
No, that means constant whatever thing you have here. That's a constant acceleration. Number 9 means constant acceleration because that's you have is an acceleration against time. That's constant acceleration. Constant acceleration. That's constant acceleration because that's acceleration against time. Assuming the value here is 10, if this place is 10, that means it is 10 meters per second squared constant acceleration. What about number 10?
Number 10. I think it's a rest.
Number 10, check it properly. That's acceleration against time. What's the value of the acceleration? 0, is it not?
Yeah, but the time is still moving.
So it's zero acceleration. Zero acceleration simply means what? Constant speed. If something doesn't have an acceleration, it means it is moving at a constant speed. Did you hear that?
Yeah.
I said zero acceleration means what?
Zero acceleration is constant speed.
So if you check, number 10 is the same thing as number 1. That's constant speed. No, number 10 is the same thing as number 4. Am I right? Look at it. Number 10, zero acceleration. Number 4, also constant speed. Both of them are constant speed, zero acceleration. Number 10 and number 4 are describing the same motion. Did you see that? Okay.
Yeah.
Acceleration of free fall will look like number 9 because acceleration of free fall is 10 meters per second squared. Constant 10 meters per second squared. Anyway, it should be observed that for a speed versus time, that's speed against time graph, the area under the graph is distance, of course, because when we talk about speed, it's a scalar quantity, so it corresponds with distance, which is also a scalar quantity. So if it is a speed against time graph, the area is distance. But if it is a velocity against time graph, the area under the graph is actually displacement. We need to differentiate between that because speed itself is distance over time. The velocity is displacement over time. We've already established all that. So that's why the area under a speed against time graph will be distance. But the area under a graph of velocity against time graph will be displacement. Although at this level, we could basically be talking about distance, you know, even though in some cases it might be displacement that we actually have to talk about. Of course, that difference should be recognized at higher levels. But for this level, we can, or at this level, we can just confine our discussion on speed and distance. So speed against time graph, the area under the graph is distance. All right, we need to take note of that. Okay. For instance, this particular graph, the green one moves from A to B and then B to C. The motion in blue is just B to C, D to C directly. By the way, D to C is a constant deceleration all through the motion. For the green one, there's a first constant deceleration from A to B, and then there's a lower constant deceleration, because this is now a smaller slope. B to C has a lower slope or a lower gradient than A to B. So this is a constant, higher constant deceleration, A to B, then lower constant deceleration, B to C. Two different decelerations. But the blue one has a constant deceleration from start to finish. Okay, assuming we're asked to find the distance covered. Remember, the distance covered is the area under the graph. The area under the graph will give you the distance covered. So for the green, the motion shown in green, let's first of all find the distance covered from A to B. A to B. What's the shape of the area under the graph? Remember, when you're talking about area under the graph, you measure it until you get to the time axis. So this whole place. The shape of the area under the graph is a trapezium. It has 4 sides. 2 of the sides are parallel. The ones that are facing each other. So that's a trapezium. The formula for the area of a trapezium is half times sum of parallel sides times height, which is actually perpendicular distance between the parallel sides. This is what I mean. Look at the sides that are parallel. Parallel lines run in such a way that they will not meet. So like these 2 lines are parallel, parallel. But these 2 lines are not parallel. Let me represent it with a different color. These 2 lines are not parallel because they will eventually meet. But the ones that are running in such a way that they will never meet are parallel lines. So in this trapezium here, we can easily spot the 2 parallel lines. That's O to P, O to A, sorry, OA is parallel to P to B. So OA is parallel to PB. So the formula is, for the area of a trapezium is half times sum of the parallel sides, then times height, which is the perpendicular distance between the parallel sides. So the parallel sides are 15, from O to A, 15. So let me write it down. Half times, let me use a different color. Half times sum of parallel sides, which is 15, plus this one is 15. That's O to A is 15. Then P to B is 5. So plus 5. You close the bracket. Times height, which is perpendicular distance between the parallel sides. The distance between the parallel sides, perpendicular distance is 4. That's 0 to P. So times 4. Times 4. That will give us half times 25 times 4. No, half times 20, sorry. 15 plus 5 is 20. Half times 20 times 4 will give us 400. 400. Is that 40? That's 40. 40 meters. That's the distance covered. So distance is 40 meters. Distance is 40 meters. That's the distance from A to B, which is the area under the graph, until you get to the time axis. If we wanted to find it differently, we could have divided this into two equal parts. We will still get the same answer. Assuming we decided to divide it like this, we have the first part, I will call it P, and then the second part, I will call it Q. P and Q make up the trapezium. So you can divide it into two equal parts, find the area of the first part, which is usually a triangle, half base times height, and then find the area of the rectangle, and add the two, you will get the same answer. So now, assuming we are asked to find the distance covered from D to C, D to C, what's the shape of the graph under the blue line? That's a triangle. That's a triangle. So we find the area of a triangle. And the area of a triangle is half base times height. The base is 10. By the way, this place was initially 8. So the base is 10. Half times 10 times height, which is 20. So half times 10 times 20. Half base times height. Half base times height, which is half times times 10 times 20, which will give us 100 meters. Okay, that's how to find the area, to find the distance of in a speed time graph. Find the area under the graph. Obviously, the blue line covered more distance, covered 100 meters, while the red line covered, the green line covered only 40 meters. Okay, another question may be to find the average speed. Average speed is total distance for total time. So for instance, find the average speed for motion D to C. With D to C, D to C. Average speed is total distance. The total distance is what we've calculated already. By the way, let me clean this. The total distance is what we've calculated already for D to C. We got 100 meters. So that's total distance, which is 100 meters, for total time. Okay, sorry, this is where we are solving it. Total distance, we found it to be 100 divided by total time. The total time is 10. So it's 100 over 10. So if the average speed for motion D to C, motion D to C is, average speed is total distance over total time, and the total distance is 100. The total time is 10 seconds. So 100 over 10 gives us 10 meters per second. Now, if you're asked to find the deceleration, find the deceleration from A to B. Find the deceleration from A to B. Where's A to B? By the way, A to B is a deceleration. A higher deceleration than B to C. Find the deceleration from A to B. You can use A equal to V minus U over T. V stands for final velocity, U for initial velocity, and of course T is for time. So from A to B, the final velocity is at B. So this one with small v. The initial velocity will be at U. This one with small u. Okay, so acceleration means final velocity minus initial velocity over time. So final velocity here is 5. We trace it to the velocity axis. Final v is 5. So we have 5 minus u, which is initial velocity, is 15, over the time from A to B is 4 seconds, which is here, 4 seconds over 4. So that will give us minus 10 over 4. And minus 10 over 4 will give us minus 2.5 meter per second squared. Okay, so but it's asking for deceleration. Since it is deceleration, we don't need to state the minus. It is simply the positive value, which is 2.5 meter per second squared. Since the question is about deceleration, we don't have to show the negative value. Okay, that's that about that. When we're looking for deceleration, we could have found the slope too, changing v over changing time, which is v minus u over t. Okay.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.